All right, let's look at our next few problems. We have 10, 11, and 12 are going to focus on composition and decomposition of functions. And then 13 and 14, we're going to graph based on our notion of um, transformations. So for number 10 and 11, we're using these functions, f of x equals 2x squared minus x minus 3, and then we have g of x equals the square root of x, and then plus 2. All right, and we want to figure out what g of f of x is. Okay, so remember this is the same thing as saying g of f of x, which is to say we put the f of x into our g function. So when I do that, I have my g function, right? And I'm going to put something into that function. In this case, I'm going to put 2x squared minus x minus 3. So that's pretty straightforward. There's not a lot I can do to simplify that. Now, now it asks me to have the same thing but evaluate it at 1. Well, because we already have the function, pretty straightforward. I can just take my function and put in 1s. And evaluate. So I have 1 squared is 1, and times 2, so that's 2. 2 minus 1 minus 3, or 2 minus 4. So that gives me the square root of negative 2, and then plus 2. Okay, so we have a couple things that we can say here. We can either allow our solutions to be in the complex plane, or we can say this is outside of the domain of g of x, and so we can exclude it. Okay. So we can approach that in 2 different ways. Now, because we already knew what g of f of x is, I could go straight to this step. Another option is if I didn't have this already, and I see g of f of 1, I can think that's taking the number 1, sending it through the f function, figuring out what that is, and then sending that through the g function. Okay? So in that case, I would have the 1 going through my function here, and we already know that that's negative 2. And so I'd put my negative 2 into my g function. So then I have square root of negative 2 plus 2. And we also, we do the same thing. If g doesn't allow negative numbers, then we can say that's outside of the domain so that we have a non-solution, or we can say we're allowing complex numbers. All right, when we're dealing with decomposition, so say in this case we want our decomposition to be represented as g of f of x, or sorry, let's make it f of g of x. So I want to find a function for g that represents kind of something being put into another function f. And in this case, it's pretty straightforward to see that g would be, we could say g is all of that inside stuff, and then f just takes something and takes the cube root of it. So g would then be all of my stuff inside. That's a 5. Okay. All right. So now 13 and 14, we're going to graph. So it's important to try to have a sense of what the underlying shape is. So in this case, we have, I might call this g of x. G of x is just our standard square root. And if I put in 0, I get 0, right? And if I put in 1, I get 1. And if I put in 2, I get the square root of 2. And if I put in 4, I get 2. And so I kind of get this slowly crawling up situation. It's more smooth than I'm drawing it, but that's kind of our baseline. then we just need to say, okay, what have I done to this? Well, internally, I've shifted it, right? So that's a horizontal shift. And then I've also externally, after the fact, I've shifted, so I have a vertical shift as well. So then I think, if I wanted my inside piece to get back to 0, what would I have to put in? Well, I'd have to put in a 3, because 3 minus 3 is 0. So I know I've shifted over to the right 3. And then, of course, anything that I do after I've done it, I add 2. So I'm bumping everything up by 2. So now I have 1, 2, 3, 1, 2. And so I start there, and then everything after that goes along about its business. Have that same kind of slowly climbing shape. Okay. Now we can do a similar thing with our function over here. In this case, our base function is just 1 over x. And if you think about what 1 over x is, if I take a big number, it makes it small, and if I take a small number, it makes it big. And if I put in something negative, it remains negative, and if I put in something positive, it remains positive. So our base function looks something like that. 1 maps to 1, 2 maps to 1 half maps to 2, and same sort of analogous thing on the negative side. So now again I want to say, what happens to me? What have I done to move from my g of x to my h of x, or sorry, from g of x to f of x? Well, I did something internally to my x. I added the 3, and then after the fact I subtract 2. So that tells me I need to put in a negative 3 to counteract that. So I've shifted over 3 places to the left, and then I've also shifted down 2. So I'm going to move over 3 places and move down 2, and this point here becomes kind of my new space in there. So if we think, like, if this was -1, -1, now I have that point there, and then if I go up 1, I have this point. So my shape comes through here, works its way down, and then same thing comes through here, works its way like that. So the black represents my f of x. Okay, so very similar shapes, but I've transformed them in a certain way. So it's important to think about what that base shape is and how I've shifted it or stretched it, or in these cases I don't have any stretching, but you can see how the shifting happens.